fine.
All right, let's go ahead and get started. See if we can finish up this chapter 21. Okay, so we left off with our reactions at night trials. Let's go down on our outline to number 7, to reactions with lithium aluminum hydride. Okay. You see that there are 4 reactions that we're going to cover here. Remember what kind of agent lithium aluminum hydride was?
Reducive.
A reducing agent, good. Okay, so we're going to get rid of oxygens or double bonds or something like that. Okay, so here's the setup. Let's look first of all at esters. Okay. Esters, when they get reduced by lithium aluminum hydride, they go to alcohols. Okay, so this is a reaction we're familiar with, back with aldehydes and ketones. Okay, so let's look at an example. Let's suppose we had this ester here, ethyl acetate. Okay. When we do the reduction reaction with lithium aluminum hydride, it's a 2-step reaction where we use H3O plus as a protonation agent at the end. Okay. So what happens here is this whole portion here gets converted to the alcohol. Okay. So this whole thing leaves, and that gets converted to CH2OH. All right, so that's the first conversion. Okay, we'll look at some extra examples when we get done with these 4. Let's go to the next reaction. That's the amides. Okay, what do you think amides will get reduced to? Amines. So the amides get reduced to amines. So let's suppose we had something like this. Where we had butanamide, and we did our reduction reaction. So here, what will happen is the carbonyl will get reduced to a CH2. To give us the primary amine there. Okay, so that's how amides get reduced to amines. Okay. Let's go to the third reaction. And that's the reduction of an acid chloride. Okay. The acid chloride gets reduced to the aldehyde. Okay. So let's take a look at an example. Let's start this time with benzoyl chloride. And do the reduction reaction. Okay. So here it doesn't convert down to an alcohol, but goes to the aldehyde. Okay, so here we have a hydrogen replacing the chlorine. Is that still a reduction reaction? It is, because I'm removing electronegative atom, replacing it with a hydrogen. Okay, so remember when I add hydrogen, that's another way to look at it, as a reduction reaction. Okay? Let's look at one more. That's the nitrile. Nitriles, what do they get reduced to? To the amines. So let's look at this nitrile here. Propanonitrile. And do our reduction reaction. Here, this one's easy to remember. That triple bond gets reduced down to a single bond to give us an amine. So a strong reduction, triple bond down to a single. So you get CH2, NH2. Okay, so any questions on those four there? Okay. Now let me give you some examples to work on, and then I'll call different ones to the board to see if you can give me the answer. Everybody got these? Okay, let's see here. Okay, so these are all reacting with lithium aluminum hydride and H3O+, so I won't write that in every time. So work on those three, and I'll call you to the board to give the answer. come and do the first one?
Okay.
All right, come on up, Puck. What's she missing? Okay, good. Good. So you get benzoamine. Okay? So this converts to CH2 and NH2 there. Good. Who wants to do the next one? George? George Tan? I'll let you do that. Very good. Wasn't that easy? Why can't it be that easy when you say it? Okay, Red.
It's okay, we just draw like the line, like we was to draw a line, if I want you to, that's fine.
Good. Okay, so here you get the amine once again. Nitrile goes to the amine. Okay. Any questions on this? Okay, you see this chapter, okay, pretty easy, isn't it? Reactions aren't too bad. Okay, so those are our reduction reactions. Okay. Let's go to number 8, look at something a little different. Okay, so here we're going to do a special reaction on esters and react them with the Grignard. And what we're going to get is a tertiary alcohol. Okay. So let's look at an example here. In order to do this reaction, it's a two-step reaction. First step, Grignard. Second step, protonation with hydronium ion. Okay. So let me draw the product, and then we'll look at the mechanism. So you can kind of see what goes on here is I end up getting 2 of those methyls adding on, and the carbonyl converts to an alcohol. Okay. So let's take a look at the mechanism. This is one that you'll need to know. Okay, so in the first step, the Grignard reacts. Remember, when you see a Grignard, we can basically cross off the MGBR and put a lone pair on the carbon that it's attached to. Okay. Where will this carbon attack? The carbonyl, as usual. Okay. So this attacks, and the OCH3 gets kicked off as a leaving group. And so we get a ketone here in our first step. But remember back in chapter 18 that the ketone can react with a Grignard. So this reaction happens a second time. Okay. So it'll attack carbonyl. And now I don't have a leaving group, do I? So now the electrons go up. So now the second methyl has added on. And then lastly, we can protonate. By bringing in the hydronium ion. And get the final product.
We don't have to draw on the side the OCH3 minus.
You can, it's not necessary. Any other questions on that? Okay. So just a couple remarks here. The first step, you have a leaving group. And the second step, you have no leaving group. Okay. So the first step is a substitution reaction. Okay, and the second step is just an addition reaction. Okay, any questions on that one? Let me give you an example, and I'll call somebody to the board. Addition reaction. Okay, so see if you can draw the product for that reaction. If you want to do the mechanism, that's fine. for this one. Come on up. Just draw the product. Need some help? All right, come on up, White. Come on up. You already had your chance, Brad. That's right. There you go. Okay, so 2 of these cyclopentanes added on. Okay, so I did cyclopentane there as a different group to make sure you're adding that on twice. Okay, so it's not a CH3 anymore, it's this. Right, wherever that is, you add it twice. You get that, George?
Yes.
Okay. Any questions on that? All right, so that's a real popular reaction that you'll see. Okay, let's go down to number 9. Okay, let's look at some compounds. They're called lactones and lactams. Okay, kind of strange names, but we'll see these are very simple types of molecules. Okay, so write it down. A lactone is a cyclic ester. A cyclic ester. Okay. A lactam is a cyclic amide. A cyclic amide. Okay. So let's see some examples of these. Here's an example of a cyclic ester. Okay, so you see the ester bond there. And what about a cyclic amide? Well, might be able to do a 6-membered ring. Something like that. Okay. So you see the amide linkage here. Okay. Typically what you see for lactones and lactams are either 5 or 6-membered rings, okay? Because those are the most stable rings, if you remember from 241. Okay? So let's suppose on the exam I gave you a lactone or lactam. How could you make one of those? Okay? All right, so what you do is we break the ester bond, in this case, all right, and we make one side an S acid chloride. And we make the other side an alcohol. See that? So you have a functional group here and a functional group here. So the molecule can do what? Chemistry on itself. You see? You see how the reaction would go? So the oxygens here would attack and knock off the chlorine. So you get an internal substitution reaction. Okay? So when a molecule can react with itself like that, that's how you form cyclic molecules. Okay? And I bet you could draw the molecule to make this one, couldn't you? Okay? So we just break here. Make that side an acid chloride. Okay? Then I count the carbons. 1, 2, 3, 4. And then put the NH2. Okay, so I got 4 carbons. 1, 2, 3, 4. Total is 6 for the ring. 1, 2, 3, 4, 5, 6. Okay? So there you can see the chemistry, can't you? Where the nitrogen would attack like that. Okay. Any questions on that one? Okay, so those are the lactones and the lactams. Let's go down to number 10. Okay, number 10, we haven't really looked at reactions with amides. But let's look at this one here, an amide plus POCl3. POCl3 has this Lewis structure. And what this reaction does is it forms a nitrile. Okay? So we haven't learned how to form a nitrile, but here we are. So let's take a look at an example. So there is butanamide. Okay. And let's react with POCl3. Okay, so what's going to happen here? The amide linkage will become a nitrile group. The nitrile is C triple bond N. Okay. So if I wanted to make, for example, benzonitrile, how could I do that? Start with benzamide. Plus POCl3. now we have a couple ways to make benzonitrile. Remember, we could go through that long synthesis we learned last chapter, or go through making the amide and reacting with POCl3. Okay. So this is how to make nitriles. Let's look at one nitrile reaction. Nitriles aren't very reactive. Basically, the only reaction they undergo is hydrolysis. What does hydrolysis mean? React with water. And what we'll look at here is acid hydrolysis. Let's look at the acid hydrolysis of nitrile. What this does is convert the nitrile group to an acid group. Okay, so we get the formation of carboxylic acids. Okay, so that's basically all nitriles can do. Other than that, they're relatively stable molecules. Okay. Let's look at one last reaction in this chapter. Okay, that's number 12. And this will be looking at the use of phosgene. Phosgene. Does anybody know what phosgene is? Phosgene is this molecule here. It's almost like a double acid chloride. Would you predict phosgene to be very reactive or not very reactive? Very reactive, okay? Because here, remember the carbonyl is delta plus, and I got a destabilization here and a destabilization there. So this delta plus is going to be gigantic. It's going to be very reactive. So if I were to react with two alcohols, those could add on real easily. Okay, we should be able to do the mechanism for that. See if you can draw the product. If I react with water. Who wants to come up and draw that from? Okay, come on up, Steelers. Very good. What did you forget?
2 ATMs.
Oh, I got it. Okay. So phosgene was heavily used in World War I. Okay. World War II, the Nazis developed it. Why do you think they used phosgene? They used it as a gas. Why would you use it as a war gas?
You only need a water certificate?
What happens if you breathe it? What's in your lungs? Okay, you got, of course, oxygen in there, but you got water in there too, okay, from water vapor and so on, okay? Not a huge amount, but you have it in there. So you breathe this in, reacts with the water in there, and guess what ends up in there? HCl starts eating at your lungs, suffocates you. Pretty ingenious. Okay, they did whatever it took to win. Okay. So phosgene gas, be very careful if you see that. Make sure you don't breathe it. Okay. All right, let's stop there for today.